Mars, the red planet, has captivated humanity for millennia. Its fiery red appearance, visible even to the naked eye, has inspired countless myths, legends, and scientific inquiries. From ancient civilizations who saw it as a god of war, to modern scientists who see it as a potential second home, Mars has always been a source of fascination and wonder. Its rusty hues, hinting at a past rich in water, tell a story of a planet that might have once been very different from the barren landscape we see today. These iron oxide-rich soils give Mars its distinctive color and suggest that liquid water, a key ingredient for life, may have once flowed across its surface. This tantalizing possibility sparks our imagination with dreams of ancient life and future exploration. Could there have been microbial life in Mars's distant past? And what about the future? With missions planned to send humans to Mars, the red planet could become a new frontier for human exploration and possibly even colonization. But what if Mars held an even more breathtaking secret, a dazzling system of rings like those of Saturn? Imagine looking up at the night sky and seeing Mars adorned with a shimmering halo of ice and rock. This vision of a ringed Mars is not just a flight of fancy. It opens up intriguing questions about the planet's history and the dynamic processes that shape our solar system. Like a miniature Saturn gracing our night sky, a ringed Mars would be a spectacular sight. The rings would reflect sunlight, creating a brilliant display that could be seen from Earth. This scenario invites us to ponder the beauty and complexity of the cosmos and the many surprises it holds. While the idea might seem like science fiction, it prompts us to consider the forces shaping our solar system. Gravitational interactions, collisions, and other cosmic events play a crucial role in the formation and evolution of planetary rings. By studying these processes, we can gain a deeper understanding of the history and dynamics of our solar neighborhood and the celestial wonders they create. From the majestic rings of Saturn to the faint rings of Jupiter, Uranus, and Neptune, these structures are a testament to the intricate and ever-changing nature of the universe. Each ring system has its own unique characteristics and tells a different story about the planet it surrounds. Could Mars have once possessed rings? Some scientists believe that Mars may have had a ring system in the distant past, formed from debris left over from a massive impact or the breakup of a moon. Over time, these rings could have coalesced to form new moons or been dispersed by gravitational forces. And if so, what cosmic events led to their disappearance? The loss of Mars' rings could have been caused by a variety of factors, including collisions with other celestial bodies, the influence of the planet's gravity, or the gradual erosion of the ring material. Understanding these processes can provide valuable insights into the history of Mars and the broader dynamics of the solar system. Let's delve into the fascinating world of planetary rings. By studying the rings of other planets, we can learn more about the conditions that lead to their formation and the factors that influence their stability and longevity. This knowledge can help us piece together the history of our own solar system and the many forces that have shaped it over billions of years, and explore the hypothetical scenario of a ringed Mars. Through computer simulations and observations of other ring systems, scientists can create models to predict what Mars's rings might have looked like and how they would have evolved over time. This exploration not only satisfies our curiosity, but also enhances our understanding of the complex and dynamic nature of planetary systems. Planetary rings are not just beautiful ornaments, they are cosmic storytellers, whispering tales of celestial collisions and gravitational dances. These rings, often seen as mere decorations, hold within them the secrets of the universe's past. They are the silent witnesses to the violent and chaotic events that have shaped our solar system over billions of years. Each particle, each fragment of ice and dust has a story to tell, a history to reveal. Composed primarily of ice and dust, these rings are remnants of shattered moons, captured asteroids, or even material left over from the planet's formation. Imagine the colossal forces at play, the cataclysmic events that led to the creation of these rings. Moons that once orbited their parent planets now reduced to fragments scattered across the cosmos. Asteroids wandering through space, captured by the planet's gravity, becoming part of this intricate dance. And the primordial material, the building blocks of planets still lingering, telling the story of the solar system's birth. Saturn's iconic rings, the most spectacular in our solar system, are a testament to the power of gravity. These rings, stretching out over 175,000 miles, are a marvel of nature. They are not solid structures, but are made up of countless individual particles, each one following its own orbit around the planet. The sheer scale and complexity of these rings are a reminder of the immense forces at work in the universe. Gravity, the force that holds the planets in their orbits, also shapes and sculpts these rings, creating the stunning patterns we see today. These rings are composed primarily of water ice, ranging in size from tiny grains to chunks as large as houses. The ice reflecting sunlight gives the rings their brilliant, shimmering appearance. But these particles are not just beautiful, they are also a record of the conditions in the early solar system. By studying the composition and distribution of these particles, scientists can learn about the processes that led to the formation of the planets and the evolution of the solar system. The intricate structure and gaps within the rings are sculpted by the gravitational influence of Saturn's moons, known as shepherd moons. These moons, small compared to Saturn, play a crucial role in maintaining the structure of the rings. As they orbit the planet, their gravity pulls on the ring particles, creating gaps and waves. This delicate balance of forces creates the intricate patterns we see, a cosmic dance choreographed by gravity. The study of these interactions provides valuable insights into the dynamics of planetary rings and the role of gravity in shaping the universe. If Mars were to possess rings, their appearance would depend on their composition and the forces shaping them. Given Mars's history and current environment, these rings would likely be fainter and less extensive than Saturn's, composed mainly of rocky debris and dust rather than ice. Imagine a thin reddish band encircling the red planet, shimmering faintly against the darkness of space. This ethereal ring system would be visible from Earth, a subtle yet stunning addition to Mars's already captivating presence in our night sky. The presence of rings would have a profound impact on Mars's environment, particularly its illumination and temperature. The rings would cast shadows across the Martian surface, altering the amount of sunlight reaching different regions. These shadows would create complex patterns, shifting with the Martian seasons and the relative positions of Mars, the Sun, and the rings. This interplay of light and shadow would influence the planet's climate and potentially affect the distribution of water ice beneath the surface. Section 5. A chilly embrace. Beyond shadows, the rings would also influence Mars's temperature. While the rings themselves would not generate heat, they would reflect and scatter sunlight, slightly reducing the amount of solar energy reaching the planet. This effect would result in a cooler Martian climate, potentially making the planet even more frigid than it is today. The rings' influence on temperature would vary depending on their density, composition, and orientation relative to the Sun. Section 6. Navigation nightmare. For future Martian explorers, the presence of rings would pose both challenges and opportunities. Navigating through a ring system would be a complex endeavor, requiring spacecraft to maneuver carefully to avoid collisions with ring particles. The ring's gravitational influence, though subtle, could also affect spacecraft trajectories, requiring precise calculations and course corrections. Mission planners would need to account for these factors when designing and executing missions to a ringed Mars. Section 7. A ringside view. However, the rings would also offer unique scientific opportunities. Studying the composition and structure of Martian rings could provide valuable insights into the planet's formation and evolution, potentially revealing clues about its early history and the processes that shaped its current state. Furthermore, the rings could serve as a platform for scientific instruments and even human outposts in the future. Imagine research stations perched on large ring particles, offering unparalleled views of Mars and its dynamic atmosphere. Section 8. The future of Mars, a ring to rule them all. As we continue to explore Mars with robotic missions and dream of one day setting foot on its surface, the hypothetical scenario of a ringed Mars sparks our imagination and pushes the boundaries of our scientific understanding. While we have no evidence that Mars currently possesses rings, the possibility, however remote, reminds us of the boundless wonders hidden within our cosmic neighborhood. Section 9. Conclusion. Cosmic curiosity. The universe is full of surprises, and our understanding of planetary systems is constantly evolving. From the smallest particles to the largest galaxies, every element of the cosmos holds secrets waiting to be discovered. Our journey through space is not just about exploring distant planets or stars, it's about understanding the very fabric of reality itself. Each new discovery adds a piece to the puzzle, helping us to see the bigger picture of our place in the universe. The question of whether Mars could have had rings in the past, or might develop them in the future, highlights the dynamic nature of our solar system. Mars, with its red rocky surface and mysterious history, continues to captivate scientists and enthusiasts alike. The possibility of rings around Mars opens up new avenues of research and speculation. Could these rings have influenced the planet's climate or geological features? What would the presence of rings mean for future missions to Mars? These questions drive our curiosity and push the boundaries of our knowledge and the intricate processes that shape its celestial tapestry. As we delve deeper into the cosmos, armed with our curiosity and ever-evolving technology, we are not just passive observers, but active participants in the grand cosmic dance. Telescopes and spacecraft are our eyes and hands, extending our reach to the farthest corners of the universe. Scientists and engineers work tirelessly to develop new tools and methods, enabling us to explore previously inaccessible realms. Each mission, each experiment, brings us closer to understanding the fundamental laws that govern the universe. We can look forward to unraveling more of these mysteries, revealing the awe-inspiring beauty and complexity of the universe we inhabit. The universe is a vast, ever-changing canvas, painted with the light of billions of stars and the dark matter that binds them. Supernovae, nebulae, black holes, and other cosmic phenomena are not just objects of study, but sources of inspiration and wonder. As we continue our exploration, we are reminded of the infinite possibilities that lie ahead. The journey is far from over, and each step we take brings us closer to the ultimate goal, a deeper, more profound understanding of the cosmos and our place within it.